So Derek, what are truly nomadic apps?
I think a nomadic application is one that can traverse between cloud providers, different regions, all the way out to edge with a consistent system architecture, right? That's free from federated architectures and essentially what cloud native has built up, which was great, limits people when they move out to edge.
Derek, you said that you cannot forklift apps from cloud to edge. Why not?
Well, what I believe is you cannot forklift them well. The issue is that forklifting an app is taking along all of the stuff that's the cloud providers have provided as well, which you don't control. And you can't actually forklift a lot of the Amazon services or Google services or Azure services. It doesn't work in terms of the brittleness, the complexity, and the speed, right? A lot of our customers are saying we need to move the edge and we can't do it over the next 24 months. How do we move get something working in the next 30 days or 60 days or within the quarter?
Some of the global largest organizations are moving from cloud to edge, and you have witnessed many of these journeys. In fact, you have helped many of Fortune 500 companies adopt Synadia's edge-native tech stack. Is there anything that surprised you about their journeys to the edge?
All global companies are struggling with competition, and technology is the big differentiator. And what has surprised me the most is how fast the transition from cloud to edge is versus how it took us over a decade to go from data centers to cloud.
How is AI impacting the journey to the edge and what you have seen among our customers and in the ecosystem broadly?
In terms of AI at the edge, I think there's two major factors. Most of the data that's applicable to both training and real-time communications type stuff is at the edge. And more importantly, the interaction models for inference is going to be at the edge. It's not going to be all the way in the cloud all the time. There are certain things that need to be faster, need to be more personalized, need to be able to access different types of data sources. And so as we talked, AI inference at the edge and that whole technology stack, which is still growing, is where Synadia is concentrating a lot of our efforts.
What are the three key differences between building for the cloud and building for the edge?
I think mostly it's batteries are not included at the edge. So what I mean by that is that when you go to a cloud provider, right, you know the app part of what you're trying to build, but everything else, the supporting structures for security, perimeter-based security with VPCs, load balancers, GSLBs, different services that the cloud provider provides for you, you can't just pick those up and move them to the edge, right? Again, it's batteries not included. And so security and discovery and communications and data flow, all of that has to kind of be reinvented. And what Synadia has been trying to do is give a technology stack for these modern distributed systems programmers to when they move to the edge, it's the exact same thing they were doing in the cloud, right? There is no step two.
What are your three favorite things about the Synadia Edge Native Tech Stack?
Number one, we don't change the what, we change the how. If we go into an engagement with a customer or a partner, the boxes and the squares and the circles that you're drawing on a whiteboard of saying microservices and access this KB and this relational store, those all stay the same. It's the how, right, that kind of radically changes when you look at the tech platform that Synadia provides. Number two is that we inverted the way we approach the problem. And what I mean by that is that most people start with the workload first. Then they realize the workload needs data. Then they need a network to connect the data. And then they figure out how they got to secure all of that. And that leads to a lot of interesting anomalies and in my opinion, brittleness around the approach. But every major technology that you could probably think of outside of Synadia, in my opinion, I could be wrong, follows that path. What Synadia did was we started with intelligent connectivity first. Then we layered data on it, and our data can take advantage of this intelligent connectivity layer so that we can move things between cloud providers, between regions, between a cloud provider and out to an edge location totally transparently because the data layer is taking advantage of the connectivity layer. And then our latest entrance, right, is workloads. And I don't want our audience or viewers to get confused. We're not trying to replace something like Kubernetes, right, which is more of a federated architecture, complex applications, lots of moving parts. But think of it like edge native Lambda, right, that has no federation boundaries, no security boundaries. It's secure, but you don't have those security boundaries. And then the other one, I think, is batteries are included, right? And so when you look at the Synadia tech stack and the NATS OSS project, which a lot of the foundational pieces are built around that, you're not looking for, oh, what are we going to do for key value store? What are we going to do for an object store? What are we going to do for load balancing? What are we going to do for perimeter security models? All of that's kind of built in a very modern and innovative way, at least from our perspective, that can translate between any cloud, any region, out to any edge.